So, my name is Mario, and first of all, thank you very much for having me here. It's a great honor. And I would like to present a continuation of a talk that I already gave 1.5 years before, and I want to see how the situation has developed. Hence, the talk is called Cross-Site Scripting is Still Dead, We Just Don't Get It. And there's one person in this room who certainly saw this talk because the initial version I gave on Hawaii, and Jim is right over there, which is pretty awesome, and I hope everybody's going to enjoy this particular talk. And let's see if we can get things work. Yes, almost there. Sorry for the trouble. All right, first a quick word about myself. My name is Mario. I'm sort of like an ex-security researcher because I just don't find the time anymore to do actual research. And I'm an aspiring lecturer at the University in Bochum, where I also did my PhD thesis. I created the company called Q53. We do penetration tests, and we're located in Berlin. And I have been serving a couple of talks and presentations, wrote a couple of papers, wrote a couple of books, and I'm currently the maintainer of the sorry, that was actually my foot. The maintainer of the software DOM Purify, which is like a specialized tool capable of sanitizing HTML in the client, in the browser only, and this tool was pretty much like the proof of concept for my PhD thesis, which was mostly about the same topic, looking at the DOM, looking at the browser, looking at trust capabilities, all in the context of cross-site scripting. You can contact me if you want to during or after the talk. You can just like drop me an email or give me a call. I don't use Twitter anymore, but you will reach me very much well with email as well or any other medium. So before we get started, I would like to see who's here this morning. Who here in the audience would call themselves a penetration tester? One person, excellent. Two people. Who here would say that they're rather a developer, a defender of web applications or similar? And lots of people, lots of developers here, excellent. Who here would rather put themselves in the category of ISO or CISOs, or more of the managerial type? Thank you very much. And who here is a bug bounty hunter? Okay, you might not like me after this talk anymore, I hope that's okay. Anyway, so the talk structure that we're gonna present today is pretty much split into 4 pieces. Act 1, the onboarding, because I want to kind of get across what I'm talking about. Then a historic overview to kind of illustrate what happened in the past and why we are here. Then I want to formulate a problem statement, and last but not least, I want to propose solutions. Most of them are pretty bad, but maybe in a discussion later on we can make them a bit better and see where we can go with these. Act 1, the onboarding. What are we going to be talking about today? So, we're going to talk about cross-site scripting. And as the talk title implies, we're going to talk about cross-site scripting, that it's dead, and we're going to wonder why it's dead and if it's actually dead, because that sounds a bit bold, I guess. Now, my first question to you would be this thing that we can see here, like this URL with the parameter called ID and the attached script tag. Is this a cross-site scripting attack? Would you say this is cross-site scripting? Who would think this is cross-site scripting, like typical cross-site scripting? Nobody. Excellent. Because that's not cross-site scripting. That's a script injection. That's basically someone trying to inject a script into a website. But we keep calling it in cross-site scripting because that term just like rolls off the tongue quite well, and it's easy to remember, but it's not cross-site scripting because the actual name cross-site scripting comes from something else. Cross-site scripting actually means that one site scripts another across origins, cross-site scripting. That is not happening here, and that is not happening in most of the situations that we actually call cross-site scripting or where we say that there is a cross-site scripting vulnerability. It's just something else. What is actual cross-site scripting, benign cross-site scripting in most cases, I guess, is Google Analytics, because there we include a script from a different domain that scripts our domain for various purposes. That would be true cross-site scripting. And maybe this naming flaw is one of the reasons why we don't fully grasp the attack and why we don't fully grasp how we can fix it. But we still want to kind of talk about why I believe that it's actually dead and that all of this might be unnecessary. Anyway, we don't want to make it overly complicated. Let's call this whole thing, this one here, cross-site scripting, and be fine with it, because as mentioned, it's just like very easy to remember and it goes off the tongue quite well. There is supposedly 4 kinds of cross-site scripting. The first one would be reflected cross-site scripting. That's the thing that we just saw. Like someone enters something via a parameter and then it shows up in the page because the result is not being filtered properly or escaped or encoded properly. That usually happens only once. You go to a page, you have a random parameter, you inject your code, and then it reflects. And then if you leave that page, then the payload doesn't work anymore because on the next page, of course, the parameter is missing. So it's reflected. Then we have persistent XSS, that it's the kind of XSS that is stored in a database or in a file system that basically stays after you left. You put it somewhere, it gets written to the database, and the next user comes, gets the payload reflected again, and hence it has certain amounts of persistence. Then there's DOM-based cross-site scripting, which makes use of DOM properties that are not securely handled, which effectively means, for example, someone is touching location href or location hash or any other DOM property, and then puts their content into an eval or inner HTML or anything else that is capable of turning a string into actual code. Needless to say, a DOM XSS can also be reflected, can also be persistent, so it's kind of getting a bit blurry already. Then there is mutation XSS, a rather nasty kind of cross-site scripting, because that is a kind of cross-site scripting that first looks very benign, and certain layers of the stack that fuel a web application would say, that's actually okay, we can work with that, that validates, we don't have to sanitize anything. But once the browser touches it and does some transformations internally and optimizations, it all of a sudden turns into something that can execute active code on people's websites, and hence is very tricky to detect and rather dangerous. There's also blind XSS as another category. That would be the kind of cross-site scripting that you as the attacker don't necessarily see, because you inject something here and maybe it executes somewhere in someone's backend or intranet or something like this. Double the dangerous, but very sneaky and harder to test for. I would say those categories are highly debatable, but in the end we can go with them because that's all we have right now. Let's go back in time and see how it all started. And let's go and call that year where cross-site scripting was first found / named / categorized the year 0, the XSS Miss Miracle. And hence we enter the historic overview. We want to learn about how it all came together and what kind of caused the whole XSS topic and this whole vulnerability scheme to still be here despite 20 years having passed. Because the year 0 after XSS is effectively the year 1999. And in this year, cross-site scripting was given a name. And people were quite insecure about how to call it at first. They wanted to call it unauthorized site scripting, USS. They wanted to call it unofficial site scripting, USS. They wanted to call it URL parameter script insertion. That's a bit, that doesn't really work with, you can't really spell this and pronounce this. They also wanted to call it cross-site scripting, synthesized scripting, and last but not least, fraudulent scripting. There was indeed a list where people sort of could vote and could have kind of decide what name they liked best. And in the end, cross-site scripting made it. And then they realized a terrible mistake because they said, well, cross-site scripting, CSS, that's a cool abbreviation. Oh, we have it already, damn it. So, well, they decided to call it XSS because that was not taken yet and simply went with that. The naming was wrong, but it was more or less a spontaneous decision that was like changed last minute again because of the CSS versus XSS. But here we are, now we call it XSS. I would have liked unauthorized site scripting the most. It's not that nice to kind of squeeze out between your teeth, but in the end that is like more truthful than any of the other names, but fair enough, cross-site scripting as a term made it in the end. Soon after that, soon after it got a name, a CERT Advisory was issued. And it said a website may inadvertently include malicious HTML text or script into a dynamically generated page based on unvalidated input from untrustworthy. When a web server does not adequately ensure that generated pages are properly encoded to prevent unintended execution of scripts, and when input is not validated to prevent malicious HTML from being presented to the user. That's quite accurate. Like in the year 1999 and the year 0 after XSS, they had this very accurate description of the cause, and one might think, well, if we have this accurate of a description of the actual problem, we should be having an easy time to fix the whole thing. Back then, there was no experts on the field cross-site scripting. Now we have that, but back then there wasn't because it was just so young. And it was so simple to grasp that there was like so-called interdisciplinary expertise. Like people who were experts in entirely different fields all of a sudden had something to say about cross-site scripting. There was, for example, Lincoln Steen, who was a human genome researcher at Cold Spring Harbor Laboratory and author of a book on web security. Well, this was kind of possible back then to be an expert in both. And he said cross-site scripting allows a bad guy to trick an innocent guy into running code the bad guy wrote. Sure, fair enough. That's also a valid description. Then there was the development side. commenting on the issue and developing ideas on how to actually prevent cross-site scripting. And the one that I like the most I found on php.net in the comments, which is like an excellent source of information. And it's from Jake_McMahon at hotmail.com. And he states that this function, and he's talking about a filter function, about an encoding function, this function is particularly useful against cross-site scripting. Cross-site scripting makes use of holes in code, whether it be in JavaScript or PHP. Really? XSS often, if not always, uses HTML entities to do its evil deeds. Really? So this function in cooperation with your scripts, particularly search or submitting scripts, is a very useful tool in combating hacksaws. Right. I think you didn't fully get the point, but at least you could see that this community also looked for solutions and slowly, piece by piece, came closer to develop something that might actually work. So back then, in the early years, we had not that many tools to combat cross-site scripting. We just learned that it existed. And the tools that we had were basically content transformation related. We would escape things before processing them, and we would encode things before echoing them or using them any further. And technically, we could say, well, that was already it. We're protecting our database, we're protecting the output, no more SQL injections, no more cross-site scripting. Done. Case closed. Turns out, it wasn't that easy, and case was not closed because those things were simply forgotten in most situations or people were not aware of it. So other measurements needed to be taken, and in 2002, with the release of Microsoft Internet Explorer 6, one of the best browsers ever, specifically Service Pack 2, a new feature was introduced that was called HTTP-only cookies. And HTTP-only cookies were explicitly invented for the purpose of fighting cross-site scripting attacks. Because now, the evil attacker cannot steal cookies any much longer. Like, cookies are now safe and secure. Big win, huge win. Cross-site scripting defeated? Well, I don't think so. Because it turns out that in cross-site scripting attacks, the attacker is interested in a lot of things, not just cookies. I mean, why would I be interested in cookies? Yes, they might allow me to directly impersonate the user, but there are so many more powerful things I can actually do. So this wasn't really doing anything, but it's still around and still being recommended. And we still write our tickets and pentest reports when we notice that someone is missing the HTTP-only cookies, although we all know that they're fairly useless in most situations. Meanwhile, these days, cookies are frowned upon, and there is presentations and work and research that basically says we should get rid of cookies, we should get rid of them altogether. And the hot stuff that is happening right now is pretty much HTTP state tokens. I urge you to look at this because this is very interesting. It's coming from Mike West. And it's a far better approach of getting rid of cookies than, for example, thinking about storing everything in local storage or the likes, because that's a horrible idea. And let's see where this goes. So maybe HTTP-only cookies will lose the final bit of reason for existing and will be deprecated by HTTP state tokens. So we have encoding, and we have escaping, and we have the possibility to use the browser to invent new features that prohibit access to certain credentials. Let's add something that we call trust. And to be quite honest, if we're at the point on the internet where trust has to be added, then the security of something might already be quite broken. Because trust is rather a wobbly term. And trust was first added in this particular realm with the invention of restricted iframes. We all know sandboxed iframes, I guess, like these iframes that allow us to embed other people's pages, and we give them an attribute that says sandbox, and then they can't execute JavaScript anymore. It's a great thing. But before those, we already had restricted iframes, another invention that was added in Microsoft Internet Explorer far, far, far before sandboxes even existed. And we could basically say, hey, here's an iframe. This iframe loads a certain resource, and the certain resource can't execute any JavaScript, so we should be fine here. So we had additional tools: content transformation, escaping things before processing, encoding things before echoing them, and now content restrictions. Can't access cookies anymore through JavaScript, and certain things can't execute JavaScript anymore in the first place. Define who and what can do what and where, which is quite nice, but you can also see that it adds complexity. And we're still fighting, we're still struggling to fix this general vulnerability pattern. Then, of course, another problem appeared. I hope I got the headline right, I'm not super sure. I use Google Translate, I have to admit. It's supposed to say something like yuck worms, because we're talking about worms, about cross-site scripting worms. Cross-site scripting, as people figured out back then, can do a lot of things. Pretty much anything the user can do in the DOM. You can perfectly impersonate someone in the DOM and do all the interactions that the user can do as well. Clicking and submitting and reading stuff and modifying stuff and interacting with the password manager of your browser and so on and so on. And someone found out at some point that you can use all the JavaScript that you might be able to inject into other people's websites to create something that is self-propagating, that basically propagates over the website, and other people who would visit that website would be getting infected too, their profiles would be getting infected, and then you would have an actual worm, like a worm-like outbreak just done with cross-site scripting, which is pretty cool. And it took only 3 years for researchers and the bad guys to find out that it's possible, because in the year 2002 there was the first write-up about the Advogado virus. And the Advogado virus was an XSS worm. If you look at the description of this thing, this fulfills all the characteristics of an actual XSS worm. Then, a couple of years later, there was Sami Kamkar, who wrote the Sami worm, or the, how was it called? The MySpace worm, effectively, where he wanted, as he said himself, impress his girlfriend by showing how many friends he has on MySpace, but that went sideways, and all of a sudden the MySpace servers were down because his worm actually propagated with exponential rates, and the FBI found him and put him in jail. So that was not that good. Then a couple of months later, there was a very thorough write-up from Wade Alcorn, also about cross-site scripting viruses, and he quickly also referred to the possibility of having them be wormable, having them propagate themselves and infect other websites, other people, and so on. And the following years were accompanied by more XSS worms and similar publications, so that concept actually worked. JavaScript was already powerful enough, and so were browsers. Now, you might notice that in this particular situation, you just don't need a small and simple JavaScript injection. You need something more powerful, and usually those worms came together when working on websites who were accepting users or user-generated HTML. Something such as MySpace, where you had the possibility to influence the looks and the optics of your profile and use actual HTML. So they would allow you to post HTML to their servers, and then they would sanitize that HTML and make sure that there's no bad stuff in there, and only the remaining good parts would be added to the database and then shown to other users. So the problem here, of course, is that encoding as such is often too rigid. We want to also be able to allow users HTML and not encode all the HTML, but tell apart the bad from the good parts, and we can only do so with a tool that is called a sanitizer. A sanitizer is effectively a tool that accepts a string, then it mangles that string and does things with it, either by their regular expressions or in smarter ways, and then what falls out is a string of HTML that is considered safe. Safe meaning no scripting, no interactive content, no forms, no pollution, no denial of service, just plain presentational, maybe semantic HTML. There's a lot of sanitizers, meanwhile. There is HTML Purifier, which is written in PHP. And it's actually, despite being written in PHP, a very good tool. Then there's Anti-Sami, which is pretty much dead, but I think it's like now more or less maintained by Mike Samuel, who calls it OWASP Sanitizer Project or something like this, which is very, very good. There's HTML Lot, which was quite bad, but it's getting a bit better. There's WAS HTML, a horrible sanitizer that's completely broken but still being used by a couple of tools. KSS, that was horrible in the past, but now it's a bit better. Safe HTML, Sanitize HTML, HTML Sanitizer, HTML Dash Sanitizer, HTML Space Sanitizer, HTML Rule Sanitizer, and last but not least, Google's Kaha, which unfortunately is not being maintained anymore. You might see that my own sanitizer is missing here because I don't want to smack talk my own stuff, because all these solutions here had one problem. They have all been bypassed at some point. They have all been broken at some point. And when you bypass and break a sanitizer, well, then it loses its purpose. So a sanitizer needs someone to maintain it, and someone who's really versed of the matter and can actually maintain it, can fix bugs, and so on. And I love this statement from the KSS maintainers. It's an outdated statement, we have to admit that, but it's just brilliant. KSS is an HTML, XHTML filter written in PHP. It removes all unwanted HTML elements and attributes, and it also does several checks on attribute values. KSS can be used to avoid cross-site scripting. Note, I don't have time for KSS right now. This is awesome. Like, this is definitely the sanitizer you want to use, right? Where the maintainer says, no, I don't have time for this, so I'm not going to do this anymore. Anyway, not really secure, not really a great concept, because all of them, as mentioned, have been bypassed in the past. Some of them have fixed their bypasses, some of them have tried to fix their bypasses but failed, and some simply didn't care. well, then don't write a sanitizer in the first place. So maintaining a sanitizer is a tough job, and you have to be aware that at any point in time, even if you're on vacation, someone might find a bypass and you have to fix it and you have to deploy it. So it's not easy work, and most of the maintainers actually didn't see that. Some do, many don't. So much secure, not really. XSS is dead? No. We're seemingly not smart enough. We're trying to develop tools that actually can defeat this vulnerability class, but none of them really work holistically. Either they're too strict, or they're addressing the wrong thing, like for example HTTP-only cookies, or they're just under-maintained and not functional because skill is missing, or motivation is missing, or engagement is missing. So we're not there yet. The tools we have right now are content transformation, to escape things and to encode things, content sanitization, tell apart the bad from the good and leave only the good, and last but not least, content restriction, define who and what can do what and where. Technically, we should assume that those tools can fix 99.9% of all cases of cross-site scripting, but as mentioned, we're sort of not there yet. So something seems to still be missing. Well, we do have most of cross-site scripting covered, but we just have to remember to actually implement it. And we're looking at the year 8 after XSS. And we want to find out how many people have actually invested time into studying and researching cross-site scripting. And I checked Google Scholar, and I checked the custom date range from pretty much the invention of cross-site scripting, 1999, to the year 2007, and there was already 1,930 papers about cross-site scripting, 1,930. Yet we still haven't solved the problem. If that would happen in medicine, we would have a severe problem. Anywho, we need to, of course, also think about all those niche cases. What about DOM XSS? What about M XSS? What about this? What about that? What if the tools that we do have are actually not enough to fix all of it, to kind of fully eliminate the vulnerability class? Unfortunately, that's the case. And there was lots of niche cases back then, and there still is. There's, for example, MIME Sniffing XSS, where you can force certain browsers to render a text file as if it were HTML. And then what? How do you sanitize that? You need to be aware that this is even possible. The same would go for JSON and other formats, or XML, and many other things, or PDF, or presentations. We saw a case once where you had a conference server where you could upload your slides, and the slides were uploaded as PPTX, PowerPoint. And then when you wanted to download the slides, you would get raw text back. Well, then you could just put a script tag into the slide binary, and then you get the text back, and then it was cross-site scripting from the slide tag. That would work as well. That's another niche case. Then there's plugin XSS. For example, back then when people had the Adobe Reader plugin installed. And anyone still has the Adobe Reader plugin installed for their browser? I hope not. No? No one? Good. Well, that had XSS as well. That was a spectacular case because the only precondition that was there to have a vulnerable website was to store one PDF in your web root. Not even a vulnerable one. You just needed to have a PDF, and that was it. Because what you wanted to do here was to use the URL to that PDF, append a hash, and then whatever name of parameter you want, could be any name of parameter, would be equals JavaScript, and then alert one or whatever. And that would work. That was like universal. Everybody who hosted a PDF had cross-site scripting. Your encoding and escaping and restrictions and trust models, they don't work here anymore. So that's a niche case that is completely off the grid and needs special treatment. Oops. Sorry. So as we can see, the tools are not enough. Encoding is not enough. Sanitization is not enough. We need stronger tools. We need something that is as granular enough as to decide when to execute scripts and when not to execute scripts. Something that can make decisions or at least generate policies where the browser has enough material to generate decisions on its own. And the thing we're talking about is probably something that everybody knows here, that is content restriction 0.5. Content restriction 0.5 was born in the year 5 after XSS, and it was getting more serious in the year 8 after XSS when first implementations took place. This was developed by Jervis Markham and was a genius idea. Only that someone else then took the idea and turned it into something else because they turned it into content security policy and just renamed it, rebranded it, and all of a sudden someone else owned it, which was not very nice. But anyway, that was the beginning of adding more granularity and more checks and more power to the browser in other instances and controlling JavaScript execution and the likes. Content security policy is a tool that I personally don't like. And I also think it's dead, and we're going to get to that in a second. I think the idea at its core is great, but it became something that is too complex because what they try to make out of it is pretty much a multi-tool that can do anything. regarding to the security. You can set headers from your server and instruct your browser to do things, and the original plan was to kind of restrict scripts and content from executing, but what actually came out was like HTTP leak protection and privacy tools, and tools to kind of manage whether your page is loading in SSL or not in SSL, TLS or not in TLS, and so on and so on. It became something that is so bloaty and so complex that sometimes developers don't really have a chance to understand what is going on and generate policies that make actual sense. We see stuff that we would refer to as LB or cargo cult CSP rules that don't make any sense at all. They just eat up bytes with every request and every response. We've seen CSP rules where you could say, well, we have a massive CSP rule pointing at tons of URLs, but we also whitelist everything. Then why do you have it in the first place? It makes no sense at all. So I don't think that this particular idea is on the right track, and we're still not there.
Mark?
Yes?
You feel the same way about like Spagnuolo and Weichelbaum's strict dynamic policy research?
No, because I think they're just like spot on. They kind of address one specific issue, whereas CSP tries to address them all, which is like an approach that is doomed to fail. And others agree, actually, because here's a statement from Mike West that is pretty much answering your question. Content security policy is a thing. We've been iterating on it for years and years now, and it shows. The backwards compatibility constraints are increasingly contorted. We've moved past scope creep into scope kudzu, and the implementation status between browsers is inconsistent at best. I think it would be somewhat irresponsible to make these problems worse by starting on another iteration of CSP that did anything other than remove features, and I don't intend to do so. So one of the creators of CSP says, it's dead, we can't have it anymore, it's too big, it's too complex, we screwed it up. And now they're working on CSP next, so we have two standards. And there's much more that people actually added to add more granularity and more control for browsers to do stuff to ultimately reach the goal of defeating cross-site scripting. We have sandbox iframes, as mentioned. We have sub-resource integrity. We have sub-origins, permission delegation, trusted types, referrer policies, and so many things we can do. I believe that at some point, the website's headers will be bigger than the website's body. But anyway. Here is an example on how to implement trusted types. Look at it, it's easy, no problem at all. Trusted types are cool because with trusted types, once you turn them on, you basically say we don't have DOM XSS anymore because all the possible DOM XSS things won't be able to execute code from strings anymore that they receive. You have to create an explicit policy for each thing and configure what is supposed to happen with it. As you can see here, we first set this header, content security policy trusted types asterisk. Then we define some JavaScript, const template ID equals location hash match template ID. This is apparently the parameter we want to watch. Then we say document head inner HTML plus equals template ID. If we try to do this, then it throws an error because we have trusted types enabled. So instead, we have to do something else. We have to define a template policy that says trusted types.create policy.template, create HTML, and so on. I mean, who wants to do this? For masses of things and masses of parameters. It's a great idea, but I think it's security for the rich because you have to invest a lot of energy, a lot of research, and a lot of resources into actually implementing this for your existing website. Yes, please.
What about inside of React or Angular? What about at the framework level? As a dev, I agree, but at the framework level, I strongly disagree.
Might work on a framework level, true. No. However, the frameworks need to actually implement it, the browsers need to be compatible, and so on. We still have a couple of years until this is the case. I do believe in trusted types eventually, but I don't think that it's a silver bullet for everybody to use quite easily. So this is there, and you can see how complex things have gotten meanwhile. So the tools we have are still content transformation, escaping and encoding, content sanitization, telling about the bad from the good, leave only the good, content restrictions, define who and what can do what and where, and hope that the trustee is actually trustable in this situation. Maybe it is, maybe not. So technically we are in a good position to state that cross-site scripting is actually dead, but the problem is we just forget about it. We just forget about the tools that we have, we forget about how to use them the right way, and so on. So the bug is still around. We could squish it, but we haven't done it yet. We're humans. We forget about stuff. We don't fully get things. We don't really care about all the things. We really easily get distracted by other stuff. And we have limited capacity and resources. Like, we can't remember all that stuff. I pretty much dedicated a lot of time to that in the past, and I don't remember all these things because it's such a vast and huge field meanwhile, and it's so hard to implement fully. So, we know the tools that we have, but now we look at the things that actually happen with the tools that we have. Content transformation, well, people forget to escape and to encode, happens. Or people encode and escape the wrong way, happens. Content sanitization, the sanitizer gets bypassed, happens. DOM Purify recently got bypassed. The fix was there in 6 hours, and then we had a bug in Google Sanitizer as well, and there was an XSS on the Google index page. That was cool. Our bug was faster fixed than the one in Google Sanitizer. But anyway, sanitizers get bypassed, happens, we're humans. Or the sanitizer library that a website uses is outdated, and no one updates it because they fear that the API breaks or something like this. Happens. Content restriction, implementing CSP and trusted types. Oh, it's so much work, I don't want to do it. Happens. Or if we do it, then our advertising doesn't work anymore, and all the money is going to be gone. Happens. So maybe you're not really overly motivated to fully tackle the problem. Maybe that's the actual deal here. Let's talk about the problem statement. What seems to be the problem with us not being able to fix cross-site scripting? And I think we can also generalize this to other problems, maybe in InfoSec and maybe even beyond. We're in the year 20 after XSS. We have all the research, we have all the tools, we know pretty much all those tricks. There's people like File Descriptor and Masato, and those still do research, and I think they have explored the area to the very max. They have seen it all. We know all those tricks. And if there's like one more trick, well, so be it, but we have seen it all pretty much. We know all the risks. We know what can happen with cross-site scripting. We know that worms are possible and that they happen in the real world. We do know how to kill cross-site scripting, but we don't do it. We just don't do it. And the question is why? Why don't we do it? We could do it. We have everything we need. I think there's a variety of reasons. I mean, this is just like samples. Oh, we just forgot to escape the user-generated content. This one time, we're going to fix it right away. Oh, this is a legacy system. We're building a newer one and slowly merging them together. The newer one is perfectly safe, but it takes time. We can't really afford to add security right now. We don't have management budget. Oh no, we don't use frameworks because our custom code is much better and much faster. Oh, our advertisers, they don't like CSP because then they don't have ad revenue anymore, and we don't get ad revenue, and everybody loses money. Or the developer who wrote this particular code is now selling used cars, and nobody can maintain this mess. We had this actually. So we're kind of becoming chief excuse officers when coming to these things. We're really good with delivering excuses. We can't do this because that. I was dehydrated when writing that code. That was so sad. The water was so far away, over a meter. Or we delegate guilt and responsibility. That was the filthy intern who wrote that code. That was this person. Or the project lead actually accepted the risk. Like, one XSS isn't that bad. I mean, what could happen? Who's actually going to do this in the first place, right? Or, as mentioned, management doesn't run any security budget. Or, yeah, we have like the second-tier protection against XSS because we pass scope our cookies. What are you doing? Yeah, we pass scope our cookies. And? Yeah, that's good protection. No, it's not. We had this just 2 weeks ago. Someone told us that. And of course, it was broken in 5 minutes. They took a year to build it. So, I mean, one could now assume that we can blame the others above, and we can say, well, the fish rots from the head down. It's like other people who make decisions, they pretty much leave us in the position of not being able to do anything about the problem we also want. But I don't think so. I think it's all of us. I think it's me, maybe even you, or some people here, maybe even Jim. But I think we need to kind of be more reflective about why we are not capable of solving these problems. Not only this, but also other problems in InfoSec. I think one of the reasons might be money. And this might be a little bit of a provocative hypothesis here. I think right now it's more lucrative for everyone involved to keep the things as they are, to keep the status quo. There is no intrinsic motivation to solve cross-site scripting or almost any other security bug unless you get like negative press. And I would kind of ask a provocative question. That would be, if cross-site scripting got completely eliminated, if the entire bug class would be gone, who here in this room would suffer financially? Me, for sure. I'm a pen tester. If we don't find XSS bugs anymore, well, then our reports are just half as thick and we get less money. So that would suck. And I believe that some people here in this room would also suffer financially. Bug bounty hunters for sure, penetration testers for sure, and a couple of other people as well. So it's actually not the worst to have all this mess around, right? Like all this dirty InfoSec stuff, it's actually quite cool that we have it. Otherwise we wouldn't be here in the first place. So the question is that we have to ask ourselves what we actually really want. Do we want to solve XSS and other problems as well? Or do we just pretend that we do want to solve them and what we actually want to do is make money, hang out, and drink together? Could be possible. Wouldn't even be the worst thing. So, what do you think? Do we want to solve cross-site scripting once and for all? Or do we want to leave things as they are? Who is here for solving these issues, for really actually putting like an end to this? You better raise your hand right now. Who wants to leave things as they are? Anybody? Yes, I like the honesty. I kind of also want to leave things as they are a little bit, but then I'm torn. Anyway, now the question is, what do we do now? Like, where do we go from here? I mean, this is a keynote, and after this, the conference happens, so we need to kind of have some motivation, some motive to actually move on to the next talks and to the discussions and all these things. What are we going to do? If we want to solve XSS, do we really need more tools? Do we really need another CSP? Do we really need CSP next? Do we need RATUR or whatever other proposals? Do we need sec metadata? Do we need another layer in the stack that makes things even more complex? Do we need this? Do we really move in the right direction with adding more on top, with like bloating the stack even further? I don't know. Here's the thing that kind of describes the situation quite well, in my opinion, and that describes the mindset that we have right now, and I don't like it too much. And I found it on Google Groups when discussing a couple of new features for Blink. And it says, as this mechanism, and I think there was sec metadata, as this mechanism is simply an additional HTTP header, just simply one more header, there's little risk created by shipping it. Other vendors can pick it up if they like it over time, or if it turns out to be a bad idea, we can just like drop it again without fanfare. This is like the state of security right now. We don't really know what to do. So we implement something, hoping that it's going to be fine. If it's not, then we just delete the code again. Like, who cares in the end? I don't know. This guy here, I think he gets it. He is pretty much Occam's razor of the web, because he says there's a feature, I don't like it, it has to go. We need to remove complexity. That's my quest. And he was also the one to basically publicly say CSP is dead. We need to do something. We need to kind of break it apart. And he thought, github.com/mykewest/csp.next is a thought experiment. What if we broke CSP in half, removed some of the esoteric options, and built policy primitives that specifically targeted XSS on the one hand and resource confinement on the other? Yes, that's the way to go. Target the problem and only the problem, not the rest around it. And I'm really excited for this thing. Maybe indeed we can go this path and kill CSP and only go with CSP next, but I'm scared that it's not gonna work out because we tried this before with so many other technologies. We wanted to deprecate 2 standards with the third one, and then we had 3. So that didn't work out in many cases before, but let's see, I'm optimistic. Well, meanwhile, I was checking how the situation looked with the papers. And I checked round about a year ago when I first gave this talk for Jim's conference, and it turns out that until then we had 19,500 papers on cross-site scripting on Google Scholar. Oh my God. Like, seriously, who reads all these? Who writes all these? Did any of those help? Or did it just give people enough academic credit to get their PhD? I don't know. But it's just, I don't think it's leading in the right direction. And then I checked again, short before finalizing the slides for this talk. There's like about 1.5 years in between. I think your conference was in April, and now we're in August. And we have, in those 18 months, added 2,400 additional papers about the same topic. Please, stop writing papers about XSS. We have enough. We don't need another one. That's it. How many other? 21,900. Who's going to read all these? No one. They're just there. They're just rotting. That doesn't make any sense. So pencils down, please. Let's step back a little bit and look at the problem with more distance and more reflection. And let's look about what we're maybe actually missing. And I still think it's maybe the motivation to actually fix this, as we kind of talked about before with the voting, with the election. Who wants to fix things and who doesn't want to fix things? Well, maybe we can motivate people by punishing them. I think punishment is great motivation. We use it for fighting crime, for keeping people from speeding, for sometimes raising our kids. Why don't we punish developers for the security bugs that they create? Maybe just like, take some kitty litter and in it goes with a head, or something like this. Like, punish them. Maybe that doesn't work. Maybe that's an ancient concept. But maybe we can think about other concepts. Maybe gratification. Put some candy in the kitty litter or something. And there's bonus systems, giving out trophies, badges, awards, inviting them to parties or organizing parties for them. Candy for good grades. Maybe reward them. Maybe that's a good thing. Maybe we should also kind of think about responsibilities for issues and for bugs. Let's start tracking down who introduced the security bug and who reviewed the code and then greenlit it and why. And let's talk to these folks and explain to them what they did wrong. And make sure that the same issues, the same bugs don't come back with the next commit, because that happens ever so often. How about a fix of the month for developers, to praise them for like the coolest fix that they did, or like the most holistic security measurement that they installed without losing too much performance. Let's praise those who fixed the issue and spread. How? Slowly build up security culture in companies and in development communities, and replace security nuisance with security being fun and being useful and fully understood. Sustainability instead of additional complexity. Cross-site scripting fixed challenges. Stop the alert instead of pop the alert. Unit test suits plugins extra desired for XSS to find it and close it or mitigate it. DOM XSS regression tests, WebDriver, browser stack. We have all the tools to actually do this, but we don't do this. And if we do this, then in small scale, but not in large scale. Sorry. Yeah, let's show them. Let's show all of them how we actually can do this, by punishing, by gratification, by figuring out responsibilities and all these things. But wait a second, because we're again talking about others, what we would do to others. And that's not exactly great, because we're making the same mistake that we have been making all the time. Maybe we should be more reflective, as I mentioned earlier before, and start with ourselves instead, and think what we could do better before we start discussing what others could do better. And one of the things, and that's a statement that people don't always like, but I think it's important. Let's stop the bug fetish. Let's stop being so focused about bugs. We keep fetishizing the bug, but not the fix. We keep praising the finders and the bug hunters, which is okay, but we also need to praise those who develop the fixes or who develop secure code in the first place. We almost ignore all of those who do the dirty work after the bug has been found. We don't give praise to those who invested their nights and days into fixing this issue as quickly as possible and still deliver secure and stable software that is still maybe even fast. Our entire mindset in this particular community is almost exclusively around bugs and not around the fixes, the state that we actually want to produce. Maybe we could think about fixed bounties. A couple of companies actually already do this. Right now, our entire ecosystem is bug-centric. If you ask Google, for example, for bug bounty and fixed bounty and similar terms, because that's actually hard to find something like this, then you arrive at numbers where you would see there's 515 hits for bug bounty program, 515,000 hits for bug bounty programs, but round about only 2,000 hits on the entire internet for fixed bounty programs or patch bounty programs, or something that is actually constructive and productive. We keep glorifying the finder, but not the fixer or the person who created secure code in the first place. We see interviews with legendary bug hunters. We see media campaigns for bugs to raise awareness, like the stuff with Backlog. Oh my God, that was so bad. We see self-proclaimed super hackers and gurus and experts and charlatans. We see top lists and halls of fame, award ceremonies, bug hunter parties, and all these audiences with the Pope. But is it really necessary? Maybe it is. But what about the other people? Don't they deserve praise as well? I mean, can we just stop having this whole thing be so one-sided? I don't think we have a working solution yet, and I don't think I just proposed any working solution. I just kind of pointed at the problem and threw in some raw ideas that we might be able to discuss later on. And I'm certainly part of the problem as well as a penetration tester. But maybe if we all kind of stick our heads together and start realizing what the problem is, and that we're part of the problem, but that we can also all be part of the solution, maybe we can actually get there together and find a way of actually making InfoSec less of a destructive but more of a constructive field, and have more of a community feeling rather than, haha, you had a bug, look at this, you stupid developer. Because that doesn't work. We noticed for the past 20 years that it doesn't work, yet we keep doing it. So maybe we should just start by being dead honest with ourselves. And maybe we want to say, I don't want to fix the system as it is. I like it as it is. I want to keep making money, tons of it, with popping alerts. Well, fair enough. No judgment here. That's fine. You can do that. There's enough legacy web applications left where this is going to be possible. The internet is huge. It will never run out of bugs. It's not going to happen anytime soon. No one here will ever lose work if you're in offensive security or defensive security. This is like a certain job guarantee, because there's just so many bugs and so many issues out there. But then, if you're actually on that side and believe that things should stay as they are, then please don't slow down the others who don't. And maybe rethink your business model. Maybe at some point we are going to run out of bugs. I don't think so, but at least think about what you're actually doing and what the value thereof is. Or you see yourself on the side of those who say, I do want to fix things. I do want to fix the internet. I want to fix cross-site scripting. I want to fix things on a large scale. And that's interesting because then I would ask, let's discuss how. Let's kind of get together, stick our heads together. Let's do something constructive. Let's together use Occam's razor and slice off all the complexity and all the craft and all the useless things, identify the actual obstacles, and create a new post-XSS, post-SQL injection, post-RCE, and so on security business model that still works and feeds our families. Because I think that's possible. We just have to do it. We just have to think about how to do it. Right now it's very easy. Maybe then it's a bit harder, but it's possible. So I think cross-site scripting and a couple of other things are indeed dead. We just need to accept it. We just need to kind of talk to ourselves, be honest with ourselves, and realize that a certain amount of bugs that we're working with right now and see popping up left and right, they are actually dead. We just need to kind of get there, understand what we need to do, use the tools the right way, and most importantly, develop the right mindset to actually fix the whole thing, the big picture, and not just the bushfires left and right. And now I would say that's a good moment to kind of stop this presentation because I'm out of material, and let's just do it. Let's just get together and do it because we can, and we just have to want to and discuss and plan and work and build, and then something comes out that's good and everybody wins in the end. Thank you very much.